So I'm going to talk about troubleshooting. And I know you say you was familiar with the L5, which is our Logic 5 operators, the commercial side. But has anybody in here ever worked on one of these? You have, okay. So you worked on the FDCs, the FDOs. You understand it's a different animal. It has a solid state board in it. One of the first what we call programmable circuit boards that came into existence in like 1997 or something in that range, early 90s. Late 90s, early 90s, somewhere in there. And nothing's really changed with it. We update the firmware or the ZIG chip and make it do a few more different features that it was doing in previous years. But it's a pretty solid board. Haven't had major problems out of it. The biggest thing is that if you service and you maintain and maintenance these things properly like you should annually, or even if you can, every 6 months, twice annually, then you're in a position to actually make sure that you get your money's worth out of this type of system, this fire door system, and it'll last forever. I was on the job site at in Miami about 5 or 6 years ago, maybe even 7 years ago, and the whole airport was outfitted with the FDO B operator that LiftMaster provides, and there was probably over 150 operators in this facility in the airport on the conveyors, because the conveyors are fire rated. Okay, so the conveyor, you have your luggage that come through the door. If it's a fire, that door has to close and stop that luggage from traveling, because if a piece of burnt luggage make it through the other side of the conveyor, the whole airport is on fire, right? So with that being said, I was out there, we did some testing and everything, and those units had been out there like 10 plus years. And if you change the batteries in them like you're supposed to, they were still functional, hardly any problems. The little bit of problems they did have wasn't anything wrong with the unit. They was running high voltage and low voltage in the same conduit. And then they was also had a situation where you had the breaker or the main power supply 350 feet away. Then you want to use tight, 22 gauge wire? What you think gonna happen? Okay, it ain't gonna never make it. So that's one of the things that you'll see in those type of situations where it's a really big outfit that has over 150 doors. You gotta make sure that the electrician is properly engaged and understands that you gotta have the right gauge, the right wire run. Everything has to work in conjunction, because these do have an amp load. And when they underload, the amps increase. And everybody in the room knows that when your voltage drops, your amp spike, you're looking for some trouble, okay? All right, so with that being said, we're gonna jump into this. Okay, I lost some connectivity here. Let's see what happened. Oh, there you go. Back alive. All right, so this is the Logic 5 board, 5.0. And pretty much in a nutshell, since y'all have dealt with this before, I'm not going to really go into detail about it. I will say it's pretty straightforward. You have your selector dial. You have everything that you need to have to really make this unit work. Does everybody in here, for the most part, feel comfortable with just going in and hooking one of these up? For the most part? Like understanding this is where the push button station connects. This is where my radio control antenna connects. This is where I actually tie in my single button station. This is where I can actually turn the dial to programming, or I can turn it to timer to close settings and stuff of that nature. Okay, because the functionality of the unit, the O&M manual kind of tells you everything you need to know. Each setting is there. If you just read through that manual and then you actually have one to actually put your hands on. Because in my line of work, I learned that you have two type of people that can learn. It's two methods. Some people, you can just give them a book and they got it. Well, I'm not that person. You got to set the machine in front of me, get my hands in there, tear it up, and then after I tear up the first one, get me another one, and I might get the second one right. So with that being said, hands-on is everything with these particular units. So when you have one in your face and you can play in it and learn it and actually hook everything up, the photo eyes, the light curtain, go back and then tie in other things like loop detectors, then you got a really good understanding of how this thing functions in all capacity. And that's what you want to do with these particular logic boards, okay? So you have what we call the motor phase jumper, change it from 3-phase to single phase. It's actually the same board. This is a true 24-volt board, so it takes 24 volts AC. And when that power comes in, you'll get, of course, the LEDs will light up to let you know. If you ever walk up on a unit and it does not have lights on it, you know that you don't have 24 volts going to it, right? Simple mathematics, all right? So you got the programming buttons, and of course the mask button gives you the indication that it's a problem. You look it up in the manual. How many times it beeps tell you exactly what's going on with the unit, okay? Also, you know that programming button helps you also set up the mid-stop, timer to close, and other features and benefits of the unit, depending on the application and what they want it to do. Okay? You have the onboard controls. This actually makes it easy for you if you haven't tied in the push button station, but you're trying to set the limits. You have it all connected. There was a time in the past where that wasn't there, and you would have to physically take a jumper and jump between there, and it's just really dangerous because for some odd reason nobody wanted to buy a Genie lift back then. Everybody was trying to do this on the ladder and have one person at the bottom holding it. See, I remember the days, right? And it's just interesting because you see how we wasn't safe then. I don't even remember putting on the belt. I don't remember tying myself off, but now, because of the codes, because of the laws, you have to do that. And if so many people have gotten hurt over the years that you had people step in and say, hey, it's got to be some written instruction on this. It needs to be able to do this. Because true, you know, when you start dealing with low voltage, it's fine. We can deal with that. But the high voltage end, you want to have a certified electrician, licensed electrician, working with that kind of power because any given time, if you're just going out to a site and it's an existing one, you don't really know all the dynamics that's going into that power supply. Whenever it's a new construction and you actually have everything right there, it's a lot safer because you actually have, you know, pretty much the overseer there. He's watching you. Authorities having jurisdiction. But when it's an existing unit and you don't have a lot of information on it, you can find yourself in a pretty bad situation out there if it's a power supply problem. Okay. So the onboard buttons are important. Remember though that you must have. Can anybody tell me for that to work? For those buttons to work, what do you have to have on that board? You got it. You got to have the stop circuit as a normally closed circuit. It must be closed between stop and common for you to use these buttons on the board. And the reason is without that there, that voltage does not trickle down. So you can push those buttons all day long. If you do not close off the common and the stop circuit with a jumper, then that unit will not run. You got to remember to take that jumper out though whenever you put the 3-button station on or the key switch on there or the key switch with a stop, because if you don't, you're never going to get your stop button to work, okay? So the door go up and down, you push the stop all day long, it's never going to stop. You know why? Because you got that circuit closed off. It needs to be at the push button station as a normally closed circuit, and when you push the stop button, it actually opens the circuit up. Unlike the open and close. Those close the circuit to make it run. The stop circuit and the common circuit actually opens up when you press the button, okay? All right. You got the wiring terminal and the terminal bus is there, pretty much laid out for you, everything that it can do. You have your single button control. You have an interlock switch that you can tie in with the interlocking system or the dock leveler so the door don't run when it ain't supposed to if the dock leveler is in a certain position. Or in many cases, say you got throw locks on the bottom of the guys for the actual bottom bar to prevent the door from being raised up. People do that so they don't want people breaking in. Although the brake in the motor is sustainable, it's actually probably stronger than the locks at the bottom. People still want the extra security of having a lock, and that's something that's offered from the door manufacturers, and we support that by being able to tie those locks into this normally closed circuit right here to give you the ability to make this unit run. If that jumper is removed as well, you will not have the 24 volts necessary to operate this unit, okay? So either it has a jumper there or actually have to have a closed circuit going back to normally closed interlock switches on the guides, on the door, okay? You got your selector dial, we talked about that. You got your B2, your C2, your D1, E2, type T, all the way back around, programming that depending on, does everybody in here know what B2 and C2 wiring is? So typically, C2 is set up for constant pressure to close. That's typically what you would see in most commercial style operators because liability purposes, they had that set up. You could switch it to B2. Before we had logic style operators, they was mechanical. This was all done with jumpers. Remove a jumper from here to here and you got constant, put it over here and you got momentary. So that momentary pressure is there. We typically won't allow you to connect that unless you have an entrapment protection device. That entrapment protection device must be UL 325 Revision 5 compliant. And when you have that connected to the unit, it allows you to maximize and be able to utilize the closed circuit, close it, and you can walk away and the unit will keep moving. Momentary and constant pressure, okay? Whoops, sorry. Relay that was previously on the Logic 4 board is now on the power board. So it was a relay that was there That relay has been since moved to another board, which we call the power board. You'll see it shortly. And the Logic 5 board didn't need that relay on it anymore, so we moved that, but it's still a circle there for it. There's your antenna plug for your radio controls. You have your harnesses that goes back to the limits and everything from there. And then, for the most part, data communication that is typically used only in the manufacturing process to make sure that the board functions properly and that we understand that it's getting the signals that it needs for all the circuits to work. Okay? And then you have the power to 24 volts AC. That's an output and an input. So you can pull 24 volts up from that unit right there, as well as that's where it powers up the board. So with that being said, we only recommend that 3 external devices be hooked up to this unit at one time. We typically send this out with a small VA transformer that's around 20 VA. However, if you want to hook up 3 devices or more that we're going to power from this board that's 24 volts, whether that's a loop detector, set of photo eyes, a card reader, or, for instance, a motion detector. At that point, you want to bump your transformer up to a 40 VA or a 75 VA transformer. That way the transformer have enough supplemental power to actually power all of these components, okay? All right. Timer defeat is set up whenever you have a timer to close function set in the operator. You can defeat that timer for a period of time, and then once the timer defeat is turned off, the timer will work again. For instance, if I own a building and on the weekends, I want the door to always be up because for some reason that's when the building is being used the most. I can set the timer defeat and put it in place, and then on Monday morning the timer defeat is deactivated, and then the timer to close is functional again, and then every time a car comes the door will close again. Okay. Maintenance alert, we talked about the mask light. That's to let you know from diagnostic standpoint what's going on with the unit, where is the function at, where is the malfunction at, and then what if it's doing anything erratically or it's not functioning properly. Okay. And then the entrapment devices, you got the LMEP, and then you got the standard edge, which is a normally open contact circuit that is not monitored. However, you have, from a termination standpoint, the LMEP is a monitored system, and that's where you would tie in your photoelectric eyes at a UL325 or a UL325 rated terminated edge, what we call an inline resisted edge. Okay. Open, close, and stop LEDs, we talked about those. They give you an indication whichever one you push, that LED should light up. Then you got your single button as well. And then limit switches will let you know where the door is. You got a mid limit, you got an open limit, a closed limit, and a safety limit. They'll let you know in conjunction. So you can actually troubleshoot this board without even really having to troubleshoot the operator. Sometimes the board can tell you exactly what's going on with the operator, and you can kind of cut your time in half on true diagnostics of the operator. Okay. The RF, the Learn LED for the radio frequency. And then also you have the motor run relays for open and close. And then this is the power board. Okay, so the power board, you know, we dual voltage, so single phase is single phase, and then 3 phases phase. You can never change the phase in the field. You can always change the voltage, but not the phase. Okay. What you'll see here is we have a few different type of relays. The one I'll tell you first is the heavy duty start relay. That relay is in position because these operators for single phase must have a start capacitor. And with a start capacitor, in order to be able to handle that starting torque, that power, we have to have that relay in place to safeguard that. And then you have the secondary small relay in the middle. That relay is what we call subsequential, and it's there to protect these 2 relays right here, which is your close and open relay. Okay. So that relay must be engaged first before the open and closed relay can actually engage. If that relay fails, then those relays can never be activated. Okay? That's your wire harness for 115. We always try to make sure that we keep that violator label on there, because if that label is removed and you're trying to fickle in fact with that thing and you sticking it where it don't go, you might accidentally get something caught up in there, and that is high voltage. Okay? So we don't, you have some experience? Oh, okay, okay. You're just giving me a smile over there. I thought maybe you had something you wanted to let us know. So yes, that label needs to stay on there when it's not being used. Also, you have the brake harness. That power goes directly back to the line voltage brake, and that brake is what keeps the door in its position, this hold position. So the brake is always engaged on this operator. Whenever the operator is actually running, the motor is running, the brake is released. Okay? Difference in fire doors. In a fire door, the brake releases when you lose power, unless you have battery backup. On a service door operator, the brake is always holding. It releases when the motor is turning, okay? Just something to keep in mind. All right, wire harness, there ain't nothing to explain about that. And then there's your brake harness I was talking about. That's the receptacle for that, all right? Low voltage receptacle there ties back into the main board. And then this is the three-phase unit. We can provide this in 208, 230, 575, and 460 volts. All right, I want to go back to this for a second. You don't see 208 up here, right? Okay, that's because no operator in the industry is truly rated for 208 volts, okay? Not single phase. Can we do single phase 208 volts? We can, but you need to make sure you at least got that because the variance changes slightly. You have your 8 to 10% variance of plus and minus. However, if I have 207 volts standing voltage and I have a door that is maybe not sprung properly, okay, and we go to lift that up and that voltage drops to 202, 201, 205, whatever, your amps are going to spike. And guess what? You're going to start burning the motor up. You're going to burn up the relays. You're going to burn the motor up. You can lose the brake. You can lose all kind of components in this unit because it's not truly rated for that. When your voltage after startup and load and you're still at 208, you're pretty safe. And because 208 is within the tolerance of the 230. But when you drop below that, you're not safe anymore. So it's truly not rated for 208. However, if you want to use 208, we recommend you get a buck boost transformer. And a buck boost transformer will give you an extra 15 to 18% on your incoming voltage, and it will actually take you up where you need to go to where now the operator itself is getting 215, 220, 230, and it functions properly, okay? Just something to know about single phase. I tell people all the time, you know, single phase, it is what it is, but to me, if you got a choice in the matter and you can dictate what's going to be in the field, always go with three-phase. If you can tell the contractor, we want you to get three-phase, and he say yes, then you should be happy. Three-phase is more robust. It's balanced load. I always tell people it's equated to this. If I'm pushing a truck up a hill by myself, the truck probably going to roll back down on me, right? No doubt, because I'm trying to push it by myself. That's single phase, especially when you're dealing with loads, right? Three-phase, now three of us pushing that truck up. That means I'm steering it, and y'all two pushing it from the back. Now, guess what? We got a balanced load, and we're probably going to get the truck up the hill until we get, you know, AAA or somebody to come. Most cases, it look like, you know, ARP as old as I'm getting, but either one I'll take. So with that being said, I think that it comes down to knowing that three-phase is more robust. It's a better voltage because it's balanced. But in single-phase situations, you can do 230 and 115, and it still be balanced, okay? Not 208. All right, so three-phase, I just talked about that. If you look at the difference in these, you see this has what we call, right, the heavy-duty start relay, okay? You don't see that on this one. It's because you don't have a start capacitor on three-phase operators, so you don't have to have that. You just got to represent the phases properly, and you still have the safety relay that starts everything to make sure those relays are properly powered, okay? There's your wire harness. Same way as the other one, and then there's your receptacle, and then of course the violator label for protection purposes. And then there's your low voltage circuit receptacle to power back to the main board. There's the brake wires again. This will be really, really line brake, so you know you got some hot stuff there, so you just want to be careful with those boards and make sure that you have some experience. Don't send your rookie tech out there messing with this. It just ain't a good look, okay? Let's get somebody out there that's got some experience to get them properly trained. Y'all doing a lot of laughing over there. I guess y'all done sent somebody out there before, okay? All right, so in a nutshell, covering this board, I always like to do things from this perspective. You see the board is laying sideways, but it gives you a good indication of a couple of circles I have up here to pinpoint some things when you're troubleshooting. Remember, what goes in something must come out, okay? So if you do not have 24 volts right there where it says 24 volt power and your LED is not lit, you know to go back to that transformer. Go back and verify fuses. Go back to fast fuse, slow fuse, 2 amp fuse. Go back and verify that the transformer actually has voltage coming out of it. Trace that all the way back. If you have voltage coming out of it, then you need to look at your wires very closely and make sure we don't have a dead short somewhere, or we don't have something that's actually going to make contact, maybe burn the back side of the board or something like that. If you get to the transformer and you don't have power there, then you know at that point your transformer is either bad or you want to go to the high voltage side of the transformer, verify there, make sure that you have the 120 to 230 to 460 coming in. If you do, then you know you typically have a bad transformer, and you can move on to the next troubleshooting session because you can replace that transformer pretty quickly. If you don't have line voltage there, I recommend you check the overload next. So backward steps, okay? You can always troubleshoot backwards quicker than you can forward. Backward steps. Now, where's the problem at? Is it with the incoming power? Did the breaker pop? So you gotta look at those things, verify them, make sure that everything is properly aligned, and then get back to the operator. No matter what happens, if no power is coming in, you ain't gonna get anything out. So you can always check right there at your power right there at that 24-volt output to verify that you have power. And then also you may have power there and that power light may be lit, and then you may not have this jumper in place. Therefore, you're not gonna get it to operate. And then you always wanna check your relays. Your relays tell you what's going on with the unit, if they're activated, if they're stuck, if they're chattered, if they're burnt. And so you always got indications there. Another really good indication to tell you something's going on here is this. I circled that stop. If that stop LED is not lit, you don't have a closed circuit between your common and your stop. That means your push button station may have not been connected properly, okay? Your key switch probably not connected properly, or you don't have the jumper in place, okay? You can always check things like that. You can always put your meter on stuff and always check for continuity. Get you one of the good meters that beep so you ain't sitting there trying to read zeros and ones and twos and fours when nobody know what that means. Get one that you put on the harness, and when you put it up on the bus, up on the terminal strip, it gives you that beeping noise. And when you got that constant beep, you have continuity, okay? Also, I would say pay attention to your status lights up here, the open limit switch, the closed limit switch, and the safety limit switch. If two of those are open, two of those lights are on at the same time, can anybody in here tell me what they think they might have? Say the OLS and the CLS light are lit at the same time. Do you have any indication of what that would mean?
Open limit switch.
What it means is that you have the limits are not set properly. You're actually engaging the open and the closed limit switch at the same time. That motor ain't going nowhere. So the limits are not set properly. You can look at the board and see that out the gate, that is making contact with both. Only one should be open, only one light should be on at one time. And then you want to verify that if, yeah.
The wire was laying on top.
Okay.
It wasn't plugged in.
That's right.
And I didn't see it. Like, why did I not have power?
That's right. So if it wasn't plugged in, then you was creating that short. You was already, it was like it was there. It was like the switch was being made.
Yes.
Okay. So another thing that you can always tell is if the door is in the closed position and the open LED light is lit, the open limit switch light is lit, please don't push close, okay? Because if you do, that door is probably going to go down and keep going down and rip the curtain off the barrel assembly, okay? So these lights are important. So in troubleshooting, the lights can save you a ton of trouble and expenses, okay? So same way, if we got the closed LES light lit and the door is in the fully open position, and it thinks it is closed, and you get ready to open it, it's going to let you open it. It's going to blow past the stops, and metal going to go flying, and then the curtain going to wrap itself around like an old shade in the cartoon when it just keeps going, and eventually when steel and steel meet a couple of times, something happens, okay? We don't want that to happen. So pay attention to the board, understand it, know what you can do at the board to save you from actually having to physically do something. Because if you can read it at the board, then you got an indication of what you really need to do, okay? Okay, all right, we talked about L5. Now we are into the FDOB. This is what I call the granddaddy of all fire door operators. It's pretty unique system. And what you're looking at now is what I call the quick start diagram. Anybody can read this and you'll be able to hook up all of these little components. They tell you exactly where they go and they are color coded. Not saying you got to use that color wire, but I'm just saying at least you have an indication exactly where they go. So you see where the edge goes to 5 and 6. You can see at 1 and 2, you got the LMEP, which is the monitored entrapment device. The edge is a normally open contact edge, whether it's a Miller edge or whatever it is, some type of edge you got on there that will actually give you the opportunity to actually reverse this door if it encounters an obstruction, okay? The push button station, typically you see push button stations connected at 1, 2, 3, and 4 or something in that range. This one is actually connected, if you look closely, You have 8, 9, 10, and then of course you're gonna have 6 as your common. Really unique system again, as I was saying. This is one of the only boards that you're gonna see out there where the actual incoming line power goes directly to the board, okay? Totally different ball game. This is powered with high voltage, the board is. And then in the middle of the board, you'll see some type of bridge rectifier that will actually convert that high voltage over once it gets through a couple of other bridges and step down transformers. Then it'll go from AC to DC with the bridge rectifier, okay? So we're gonna get into this. I'll show you what I have over here a test key switch. You have your sounder or your speaker. This is the unit I was telling you about, the FDOB that comes with the voice board that has the ability to communicate by voice and tell you that the door is closing and it isn't an alarm, okay? Smoke detector tied directly to it, and you see your main power is attached right there on the board. Here's the board in essence, and you can see this is a 115 volt rated board. The power comes in here. If you look at these conductors here, you can see that it comes up. That power goes through a heat sink, comes back then after it's converted back through these relays, high and low voltage relays. You probably have 5 of them there, 1, 2, 3, 4, 5. Probably open close relay, stop relay, I would say safety relay and alarm relay. So you probably have all of those features right there for you in those relays. The relays are everything. You won't see these boards go bad. What you will see sometime is that the brake has the ability, because it is a low voltage DC brake, to backfeed back into the board if maintenance is not done right, or it's hooked up improperly, or your door is just so heavy that you don't have the proper tension, so you're utilizing the brake too much. It can cause backfeed from the brake back into the board. What happens when the brake feeds back into the board? Okay, you have these resistors here that get burned up, and then this rectifier gets burned up, and then it just backtracks, so you lose everything, including the transformer. And that's when you got a catastrophic moment there. You got a complete failure. You've lost 3 or 4 components in this operator that are very expensive. We try to protect the board because it's the most expensive component in the whole operator. Therefore, we try to put things in place to protect it before it goes down, like fuses, like just making sure that you don't get that high voltage power going to that low voltage side. You do that by putting in the proper resistors, capacitors, other things, that components that actually they advantageous to the whole system, to where it actually just like filters it out, like overloads, right? So, all right, so power comes in, we're troubleshooting this unit. Power comes in, rotates all the way over. By the time it gets over here, it's AC low voltage, and then it's DC, and it feeds in through the battery system that connects there, and then it goes over there to where you got those dip switches, and then you got those actual prongs, and then it goes out to the brake. That's where you feed the brake power to. So that brake is 24 volts DC, and that comes back through. So one of the things I would say about this unit is that if you can hook this one up, you're ready for any of them. So if you master this one, that's not a fire door operator you won't learn. So this one right here is before its time. Very good unit. Still a great unit today. And one of the things you can always tell, if you look up at the corner up there in the left-hand corner, you have a green and a red LED light. One is for AC power and one is for DC power. If you have AC power, the red light will not be on, okay? If you lose AC power, the red light will come on to let you know that it's still being backed up by the battery DC power. One of the ways that you can tell if you got AC power without going to the breaker, without taking out your meter and testing wires, go to the board and see which lights are lit. The AC light is lit, we have AC power, and we're fine. Then we need to just start backtracking on our circuit to make sure we have 24 volts, okay? One of the things I always tell people, this board has the ability to give you 24 volts AC output and 24 volts DC output. Hey, how you doing, sir? Awesome. So I always recommend that when you first get to this board, this particular board here, and you verify that you have incoming power, and you look over there and your AC light is lit, then what I would do, I would go to terminals 6 and 18. 6 and 18 with my meter, and there I should get 24 volts DC. If I do not have DC power right there, I have a problem somewhere in my DC circuit, okay? If I do have DC power there, I then next go and I rotate over and I go and I look at terminal 8 In terminal 10, on the bottom tier terminal strip, it's another terminal strip in here that you can look at. Let me see if I can find it, because it's actually 3 terminal strips. Yes, it is. So if you look, you have 1 through 12, and then you have 13 through 22. Okay? And then at the bottom, you have 1 through 10 for your auxiliary power. Okay? So you can always check voltage there. Okay? So one of the things that I like to do is, get back on track here, is to verify, one more, verify that I have, 24. Verify I have power, DC power output, and AC power output. And then you have voltage going in. Remember what I said? What goes in must come out. Now we have voltage going in and we have voltage coming out. So that means the power is there. From a functionality standpoint, we then have to verify that if everything is working right. Is my safety device working right? Is my push button working right? If that stuff is not working right, then at that point, you want to start looking at your alarm contact circuit. You want to see what's going on with the interfacing of it all. It's connected to a building alarm system. Is that building alarm system C-form dry contact? It should be, because no voltage shall pass between the alarm circuit on this operator. Because if it does, it will damage the components in the operator. So that must be a normally closed or normally open C-form dry contact from the building alarm system or smoke detector through a relay module. Then it comes to the unit. And then when it's activated, it's just a changing of state. It's like a switch. Closed, open. That's simple. If that system has power running through it, it would damage this operator. So you got to verify that they have a true, what we call regulated alarm system with C-form dry contact. And then if they do, it ties into the alarm circuits on this operator and functions properly. And that can be switched over with this dip switch setting up here, the little red box. You can switch it from a normally closed to a normally open, depending on what the alarm panel is set up for. Okay? So this is the only unit that's typically set up in the industry that has the ability to conform to a normally closed or a normally closed contact from the board. Okay? Any questions on this unit so far? Because this is kind of in depth, looking into the circuitry. And I just want to know if anybody has any questions before I proceed. Nope. Okay, okay. That's what I'm talking about. Y'all ready for that test? Y'all sharp up in here. All right. So, looking at this circuit board, if I was to ask to see if anybody was paying attention, because I didn't say nothing about it, does anybody know what this is? Looks familiar? Look like anything you would think you would know what it is? Okay, it's called the piezoid. Okay, it's no more than an annunciator on the board. I have seen time and time again where these units be beeping in the field, and the maintenance man gets so mad because he can't get it to stop beeping. He goes up there with a screwdriver, and he sticks his screwdriver in this hole and pop the piezoid. Well, why did you go and do that? Now you ain't gonna know when your battery's dead. Now you ain't gonna know when you got a fault. The piezoid is there to give you a noise, to actually give you a sounding bell annunciator to let you know that the unit needs maintenance, that something is wrong. And a lot of times people will not change the batteries. By the way, I told you earlier those batteries should be changed 18 to 24 months. If you choose not to change them and they drop below the required voltage, which is 22.1 volts. Once they drop below 22.1 volts, it's going to start beeping. And if you don't pay attention within 24 to 48 hours, when you come the next day, the door will be closed. That's fine if it's in my warehouse and I want it closed. That's not fine if it's in the hospital. So that's what you got to look at. Where is the unit set up at? What's the application? What do they need to do? In the hospital, they don't need it to be closing off areas. They need to be getting up out of there. So it will contain a fire. But if you have nuisance drops because you're not servicing it properly, you're going to have these type of issues. So don't pop the piezoid. Don't never let nobody talk you into popping the piezoid. You get the unit serviced, whether that's from a trickle charger standpoint, sustaining charger, or whether that's changing out the batteries, or completely changing out the board because it's damaged and it can no longer sustain and still give you proper operation. Okay? This board here goes into our AFCB. This is the LM21 AFCB board. This is actually the board that goes in the release device. This is the release device I talked to you earlier about. I gave y'all the whole structure and breakdown of it to where it actually is the brain and then the motor is the body. And when you combine them, you have a totally automated reset system, okay? So it's a total automated reset system, meaning that it can stand alone or it can be tied to the central building alarm system. The same way though, must be in compliance with a relay module, or the alarm system must put out C-form dry contacts, normally closed or open, that goes to the circuit, and then we can conform. These particular units will not take a normally open though. The FDOB will. It has a dip switch setting that allows you to change that. These units have to have a normally closed, okay? C-form dry contact from the building alarm panel or a smoke detector through a relay module interface that comes back to the unit, and then when it changed state from closed to open, sends the signal through the circuitry to gravity drop or motor close the door, okay? That will travel 6 to 24 inches per second. Complete to complete close, you will not be able to open the door until the alarm activation has been cleared or the system itself has been reset because it's no longer an alarm, okay? Once the system is set, you don't have to add tension to the counterbalance spring anymore because these are auto reset. You go up, you push the open button. If the open button doesn't work, the fire alarm is still activated. If it does work, it'll go to the fully open position and rest there, okay? That's what we covered. So this is the board and that release device. I told you about the harness that makes it plug and play with a LiftMaster L5 operator. If you take the phone jack and you plug it from this board to the FDR card in the Logic 5 operator, then you have two systems that's integrated together with the phone cord, and you don't have to do any other wiring, okay? However, if you don't have a LiftMaster operator, this release device will still function with those operators. You just have to take 13 to 15 wires and you have to hardwire them back to all of these terminal strips. So wherever you got a safety, open, close, stop, you have all of that right here, because this system is actually going to take over the motor and it's going to turn it into a fully operational motor operator. And with the reverse limits on the operator, in the reversal of the operator, with that particular mod, now you have what we call a fire door operator, whether that be a GH or H operator, it's a gearhead operator, jack shaft operator. Now it is in compliance with fire regulation, and if it's on a rated fire door. Remember, the fire door and the operator must be bought from the door manufacturer. However, the release device can be bought or purchased directly from LiftMaster and retrofitted up. As long as you have the accreditations and you have the approval, you go through a quick course for LiftMaster. We got an understanding that you know what it means and understand how to work with dropout mechanisms, compound governing systems, and understand how to actually work and service a fire door. And you can show us that you have a contract doing that, then you can purchase that directly from us, okay? This particular unit is monitored at all times. You do have a reset button here and a test button, so you can test it at the unit. It also comes with a test key switch at the bottom of the floor to where you don't have to climb on anything. You want to do your annual testing, or if they want to get it done twice annually, you just go to the wall, turn the key, the door will close and the alarms will go off as if it's an actual fire. Once you turn the key back to the natural position, it's clear, push the open button, the door will go back to the open position. Authorities having jurisdiction can ask you to test it that way. They can also ask you to test it and make the pin release. They may ask you to remove the fuse link. They might want to see it gravity closed. They might want to see it motor down. You have to give them, they reign supreme. You have to give them every test they want to see. And with these particular units, these advanced units, you can't do that, okay? Any questions on this particular system? One of the things I didn't mention that you see here, this is a board that is on top of the regular board. That is the voice board, okay? That is the same voice board that is in the FDO, okay? It just plugs into this board. So this one I'm showing you is the voice one. You see the yellow and the purple wires? That's nomenclature. That's the right wires there that's going to go to your annunciator and your sounder strobe, your speaker strobe. So this unit also has the ability to talk because this is the VB version. So the VB version is the voice board version. So it has the ability to give you an enunciating or voice, speaker voice that tells you the door is closing and in an amount of time when it's going to close. So it does a countdown for you. You can change those settings with the dip switches here. We don't have it set up for French and Spanish, but in most cases in those countries, they don't require it. So typically you will only see the voice board being used if it is a standalone system. meaning that the building doesn't have a central building alarm system. I talked to you earlier about the seizures and epileptic seizures you can have if you don't have these annunciators synced up. So with that being said, if it is a true standalone system, then in that case you can tie in the voice board and give them that warning that the door is going to close, and it does do it by voice. Okay. Has its own onboard transformer as well as the chips. You see this strip here, this of course light tells you that it's powered. If that light is not on, then you may want to make sure that it's sitting down properly on the pegs, because it can easily get off balance. That happens quite a bit when you're dealing with circuitry. Another thing I would always say is, if for instance it's not sitting down properly on the peg, because we use this board in other situations, you can power this unit right here as well with 24 volts. Okay? So, in a nutshell, that's that particular one. This is a complete monitor system, so it has resistors in place. If those resistors are not in place, you're going to get the piezoid that's on another board that's inside here that's just set up for that, and it's a sustaining and charging trickle charger circuit, and it will start beeping the same way that FDO would do. And I ask that you not let anybody, or the maintenance man or nobody, go in there and take a screwdriver and pop the piezoid. Because if you do that, you're not going to get the alerts that you need to know when it needs maintenance, know when the batteries need changing, and you're not going to know when it goes into a true alarm if you do not have an annunciator. So this is the key. That will beep and let you know that it's about to drop, so you have a pre-warning. If you pop that piezoid, it's not going to do that. And what if you don't have the annunciator connected to it? It's not going to make no noise. It's just going to drop. And if you're not prepared, you can be in a little bit of trouble there, or get damaged or hurt, or damage some equipment or get hurt, okay? So something to be aware of there. This is what it looks like completely. I told you over here we had the sustaining and the charging board, as well as a piezoid on that board, other lights on that board to give you indication. You have the 2 batteries that I recommend be changed every 18 to 24 months. Those batteries will sustain the operation of this unit for up to 72 hours. I always say 48 to 72 hours, because when you connect the voice board, when you connect, we delete that. When you connect the voice board to it, it does deplete the cells and the batteries a lot quicker. Okay, and it's a little bit more work on the sustaining charger, because you actually take a lot, it takes a lot. When you're dealing in wattage, it pulls a lot whenever you're dealing with the voice and the speakers, okay? So other components in this board that's very important to kind of pay attention to is the actual plunger, which is the solenoid, okay? If that is not getting the proper voltage that it needs to release, then the pin would not release, so it actually goes over. This is the plunger. Once it's activated, the transformer feeds it in, high voltage, low voltage, because this is a multi-voltage unit that can handle 24 volts AC, DC, and 120. However, and that's why you have the MOVs here to protect you for when you put the high voltage. Those MOVs will save your life. They will stop that amperage from going through your body. I'm telling you right now, volts never killed anybody unless you got a pacemaker. What kills you is the amperes, okay? And what it is all it takes is 0.12 of an amp to take your life. That's why whenever if anybody here got any extracurricular activities and they go out here and they like to play with the police and get hit with a stun gun, then I'm just letting you know that's why you just get knocked out, because that's 50,000 volts with 0 amps. If that amperage get in you, it will stop your heart. So those MOVs are there to protect you, so you do not take on those amps and become ground. That's one of the important things you must know about anytime you're dealing with power. Pay attention to that. Amps are very dangerous, okay? You know, that's why I always tell people all the time, if you stick something in a light socket and it's 115 volts, that amperage is so dangerous to you, because guess what? It's a high amp. So low voltage, high amps, right? So that's probably 9 amps, 120 volts. You pulling that amps into your body. It'll hold you to it. You can't let it go. If it's 460, it's so powerful and the amps are so low, it throws you across the room. Now, you're still probably dead, but you didn't get stuck on the circuit. So that's the key right there. So voltage and amps, understanding them and knowing what they mean. Amps take your life. Volts, you want to understand them, but you don't want to play with them, but that's what you're dealing with. So anytime we're dealing with this, it's about life safety. This is an electrical equipment. This is a circuit that puts out power and takes in power. You want to be aware of that as a technician. You want to know what you're going up against and what you're working with, and you want to be educated on it. So the best way you can do that is to get hands-on experience, know it, look at the educational point from a book standpoint, but get your hands on the product and actually dial into it. Know what it can take, when it goes. Take your meter. Remember I told you, don't get no little fluke. Go get you a real meter that actually gives you a beeping noise, a constant beep whenever you're checking for continuity. Okay, those are easy to read. They're great for beginners, and they will teach you how to read it. And everything is on there. You just flip the switch, and everywhere you go, it tells you what you're going to read. Okay, so that's a good thing to have. And you can get the good ones now. And you can start testing ohms and stuff of that nature. All right. So back to this, you have the plunger, you have the transformer. That plunger has on top of it, way up there, that's a actual reset plunger. Sucks in, you can push that to actually reset, and then you have the reset buttons on the side of the unit as well, right here after a test. It may be beeping, you change the batteries out, it's still beeping. Hold the reset button down for 3 seconds, release it. After you release the reset button, it should quieten down and go into normal state of operation, okay? One of the other things to kind of pay attention to is that solenoid on this end of it comes out. It's a pin. That pin is where your S hook connects. It's where your fusible link cable goes, and that ties into it, okay? We're protecting this circuit board here with 2 amp slow fuses. Those fuses go first. I would check that. If you got complete failure, you have power to this board, but you don't have any lights on this board. At that point, you know to go ahead and check these fuses, verify them, and make sure that they're okay. If they need to be replaced, replace them. I don't mean take your meter and put it right here. No, take the fuse out, because your meter can create that circuit, and then that voltage can go through your meter, the amperage can go through your meter and actually damage it, okay? So I mean, take the fuse out, test it on each end, and check for continuity. You get a beep, it's a good fuse. You don't get a beep, it's not a good fuse, okay? All right, this is the LM21XP. This is the one that ties directly to the building alarm system. Pretty simple. Not a lot going on with this unit. It's not designed to stand alone because it requires 24 volts DC power. That's the only power that it will take is 24 volts DC, so it's not a multi-voltage unit. Therefore, it has to be tied and powered from the building alarm system. So right there where you see that yellow circle is, that 1 and 2, that circle right here is the incoming voltage. That is 24 volts DC. It must be a true regulated source of DC power. You cannot take 24 volts from a transformer, run it through a bridge rectifier, and connect it to 1 and 2. Don't do it. There will be traces of AC still in there because that is not a true regulated source of DC power. It must be a regulated source. If it is not, you're allowing AC voltage to seep through this circuit, which is going to damage the board. And guess what's going to happen? On that other little board over there, it's going to make that piezoid go off, we talked about, and it's never going to drop out. So if you quiet the piezoid down so you can get off the job site, and then it's time for you to do your annual test, the door is not going to release because the board has inadequate power to it. It has the incorrect power supply to it, and it's going to damage the circuit if left unchecked, okay? So you want to make sure you got a true regulated source of DC power. Once that DC power enters the board, you'll get the right lights to let you know that you have sufficient power. You also have your reset and your test button over here. These terminals lined up pretty easy. Smoke detectors, and any regulated smoke detector or alarm system that's set up already with resistance set into it, meaning it has like a 10 KO diode or it has a resistor or something because it's monitored, that is going to connect to 3 and 4. 3 and 4 is okay to receive some form of voltage, okay? You must leave the jumper in 5 and 6 because 5 and 6 is your normally closed contact. So what that means for you is this. If you have smoke detectors that's going through a relay interface module and it's that C-form dry contact I talked about, you will put right here, remove the jumper, connect on 5 and 6, take a 10 K ohm resistor, put on 3 and 4. Okay, because that has to be monitored at all times because it's looking for something to interact with. Without that there, continuous beeping. The unit will not function. Do not pop the piezoid. Okay. I'm like drilling that one, right? I've seen that so many times, okay? So also, if this was the BB version with the battery backup, you would also have monitor circuits here, and you would have to do that same thing at terminals 9 and 10 for whenever you're hooking up smoke detector, strobes, and other things of that nature, okay? It's a lot of terminals here for you, and these are monitoring terminals. They will let you know the position of the door. It would also give you back feedback to the actual fire control panel, if it's an alarm, if it's an alert, if it's a fault. So it's self-diagnostic. It will actually work in conjunction with the central building alarm system to let them know if it's something wrong, a trouble signal from the unit, okay? There's something to keep in mind with these units. Not really difficult to work with. It's just about being educated on them, getting your hands on them, and understanding them. I know y'all wondering what this blue line is. So this is a ground fault, okay? And up there at the top is a metal stud. So typically what you'll see is these are not metal. These are plastic. So the screw goes into the plastic. But on the back end, that one screw is metal. So that one screw is metal all the way through. And what that is that's your ground. So that's to protect the 24 volts here. However, what you may have happen if somebody takes this unit and mounts it on a steel beam or a wall that has its own ground because it's grounded through the bolts or through the studs, then you got a double fault because you got two grounds. And what'll happen is this light will light up and the unit will keep beeping and stop functioning. What you can do is you can remove our ground that's already there by taking that stud out, okay? And then it'll just be controlled by the one ground. Or you can do the hard way and take it off the metal studs and put it somewhere else. But we try to give you that so you don't have a double fault, double ground fault, okay? Real simple when you think about it in awareness. That light will only come on if you have that fault. And each one of these are represented in the manual. So you have LED 4, 5, 6, 2, 7. And so if you look in the manual, it will tell you exactly which one they are, what they mean, and how to properly diagnose them. Okay? All right. This is how this unit looks, a little bit cleaner, easier. If this was the BB version, it would have the batteries up at the top the same way. It's not. This is the one that has to be tied into the central billing alarm system. So this is one of the 10K ohm resistors I told you about. We also provide the really little ones. It's just that if you got fat fingers like mine, I could never get those little ones in there, so I thought it was always good that LiftMaster provided the really big ones that actually help you out. So it's just really, really good gauge wire. You can just get in there and make it happen, right? So same way, plunger, release the pin, comes out. You will see sometime if you don't have adequate power supply, the plunger will not suck in all the way. So say for instance you have 16 volts instead of 24 volts, still might be enough power to power the board up. However, it's not enough power to actually suck in the plunger. Therefore, you will have false alarms, meaning that when it's time for an alarm to happen, it won't release the pin. The plunger will not release. So the solenoid won't activate all the way. It may do a little, but it won't go full. And you want it to drop all the way to the bottom so the pin properly release and then you can properly reset it. Don't make sense to have a fire door operator if it's not functional. One of the things that causes it not to function is the inadequate power supply. So I always want to make sure that we got the right power supply. Okay? So don't even worry about reading this. This is part of the steps that I think that's important. And what it does, it kind of just gives you an overall view if you're troubleshooting a CDO logic. And then why, so issue we're going to drill down. I call it my drill down issue. Why is it not operating and my LEDs are lit? I run through the resolution, door will not move, door issue corrected, stop circuit is not complete, stop circuit was missing, broken, stuck, or issue corrected. All the way down I go through this, and this is something that'll be posted. I'll make sure y'all get a copy of these slides. It's really important for you to understand. This is something right now that our TSC probably doesn't read down through completely for troubleshooting, but this is something that we want them to start following. It's something that will actually help y'all in the field. It'll help you get to the state of why this thing has failed a lot quicker, because you'll have a blueprint of basically just what to look for. And that's kind of what this gives you. And then I have also the scenario of why is it not operating, no LEDs lit. And that goes from anywhere in there is no incoming power to the unit, the breaker pop, turn it back on, see what you got. Secondary power, you know if you don't have 24 volts coming out of the transformer, but you got 120 coming in, we got a bad transformer. No need to go any further right there. If I don't have what goes in, something has to come out. It don't have to be the same voltage, but it better be something. And then you can kind of tell. So you might have a situation I've seen where transformers are not completely burned out. They might be taking in 120, but only putting out 11 volts. One side of the coils might have burnt up. The complete transformer didn't, but it's no longer good. It doesn't put out the adequate voltage that we need at the unit. Therefore, the transformer has to be replaced. Okay? All right, so you might have a question where no power to 24-volt terminals, correct interlock, hand chain, disengage. Make sure the hand chain ain't stuck. It's a switch in there, a mechanism, cuts off whenever you pull it. Same way with the interlock switch. You go through that circuit. It's a normally closed circuit. If it's not there, if that circuit is open because your interlock's on the door not engaged, or if actually the jumper is not in place, the unit will not function. The 24 volts does not properly go through the operational process of the whole circuit, okay? All right, I did the same thing with the FDOs. It's a little bit different, but this is good information. Why is the unit beeping? Okay, There you go. You got a list of stuff that tells you why it's actually beeping. And I even talk about the aluminum standoff removed for the ground fault. We talk about there is not enough battery voltage. Change the battery. Anywhere between 27 and 24 volts is what you're going to see on these batteries. And then also the sustaining trickle charge, or what we call, there it is. There is no 3-point VDC to the battery wires, bad trickle charge. So at all times, 3.5 volts is being trickled back into the battery. The reason why is to keep it above where it needs to be so that the unit works properly. If it dips below capability of where it's at, you get the notification through that piezoid that we don't want to pop. And then after that, you'll kind of know where you at. Okay. Another one, unit does not run, faulty interlock or disconnect, incorrect board revision, meaning you don't have the proper board. We talked about that. If you can go 500 or 600, you can't go back down if you have the monitor entrapment device. Also, unit will not drop. You want to make sure you look at the door as well as the unit. And that's why one of the most important ones, the setting is not correct on operator. Correct dip switch setting for normally open or normally closed dry contact. Okay, if you got it set up for normally open and they feeding you a normally closed, you're not going to get it to do anything, okay? All right, so you just got to make sure that everything, these are truly interfaced with a lot of different systems, okay? And you want to make sure, I mean, I've seen them on conveyors. I've seen them work in conjunction with just regular standard building alarm systems. I've seen them tied to sprinkler systems. I've seen them tied to people's lights in the building. So you want to make sure that whatever is interfaced with some type of dry contact. We don't want them pulling power off the transformer. Our transformer in this unit is a 75 VA. That's about as high as we want to go. It's taking a lot of juice just to do what it's doing to power up all the extra devices that's connected. Now you want to go and hook up 3 safety devices, motion mod, loop detector, and all of that. I recommend that you get another transformer, set it to the side, power the units through that transformer and the main power line coming back from the power supply, and then just use dry contacts or interface relay module to do the connection from the C-form dry contact. Okay, that's what I would recommend. All right, so let's see. Does not motor down, only releases. Look at the dip switch settings. Make sure you set up for momentary. Also refer to OEM manager for door support in those regards. And with that, any questions? You ready for the test? Any questions? Yes, sir. That's what I'm talking about. Yes.
What is an acceptable voltage drop?
From what power supply?
Say just one 150 single phase.
I would say that if you have voltage drop, typically, and this is, ANSI will give you the real, the American National Standards will give you the real percentage, but I would say anywhere between 8 to 10%. You can do that in voltage drop. That's minus and plus. However, from the actual line voltage, what it's rated for on the panel. So only operator will actually tell you what it's rated for. It'll have either 230, 120, or 480, right? And then you go and you say negative of that or positive to that. I want to do 8 to 10%, you're covered. A lot of times what people don't realize is that with logic boards, that variance could change slightly, especially on single phase, because you got a lot more things that's being put into the equation. Before it was just electromechanical. All we had was relays and contactors, and we just had a transformer and then the motor, and that was it. And those things were so robust, they could take any type of damage. You know, like you could pretty much, besides putting 230 to a 120, you could pretty much make anything work with it, right? Well, that day and time has gone, and with the logic boards and all of the different stuff with the battery circuits, you just can't afford to go outside that variance because it's just too much pull and push on the components in there, and they're just not built for that. When you combine all of these integrated components on one logic board, and you got all of these different capacitors and resistors that's relying on each other to do a self-diagnostic check down to make sure everything is adequate, and then all it takes is one capacitor to open up or balloon open like a rose, and when it does, you've lost a complete circuit. It will let power run through that thing unchecked and damage the complete board. So I would say 8 to 10% would be a stand. I would stand by that any day. And in all my experience in the industry, I would stand by 8 to 10%. Any other questions? All righty. Well, thank you for your time. I wish y'all good luck on the test. Like I said before, this was not like a prelude to the test or anything. I would just say to you that a lot of information that I provided today, some of that will be on the test if you're getting the fire test. And that feel free to reach out to me. I did pass my card out. Any help I can give you in the field, Anything I can do to support you, to continue to buy LiftMaster product, but also continue to just like represent the industry properly and make sure we practice life safety first. And I think that we're always on the up and up with that. So onward and upward. Thank y'all for showing up.